Hi, it's Janine again, and I will be talking about water, an agent of heat. This is my Module 4 Teach Us video. So let's talk about water as an energy agent. What I want to show you really quickly is kind of a demonstration that I put together in my house. It's not a long one, it's very short because I'm kind of limited on time, but I want to show you something to get you thinking. So I did a little video and I filled one balloon with air, one balloon with water, and then I added a source of heat. In my case, it was a lighter, just to see what would happen. So I'm going to go ahead and I'm going to click on that video and we will see what happens. So the first thing that I do is I fill the balloon with air and water. The first balloon, as you will see, I put the heat to it. Instant pop. Expected, right? Second balloon has water in it, and I put the flame up to the water balloon. But guess what? It didn't pop. It didn't melt the plastic of the balloon and cause it to burst. So what's going on here? Why is it doing this? So we're going to talk about water as an energy agent. And we're going to find out why. All right, so water. So what's so special about water? There's several things going on here. First of all, water molecules are good at forming hydrogen bonds. Now, this is different than the covalent bonds that are between the hydrogen and oxygen atoms of the molecule. These are actually weaker bonds between molecules of water. So there's, as you know, hydrogen atom, water molecule is bent. It has a bent shape. It's very polar. There's a positive end of the molecule and a negative end. And as we know from physics, the negatives and the positives attract, and they form a weak hydrogen bond. When water is a liquid, it is in motion, which means that the water molecules are moving. And so those that partially negative end of the molecule is attracted to the partially positive end. So it has more things going on than most liquids. It has the hydrogen bonds, and it has a small molecular mass. So when water has a high specific heat capacity, and it is because of that small molecular mass and the interaction of those molecules. The water molecules, they rotate, they bend, they stretch, and all of that motion, all of that kinetic energy is absorbed into that molecule. So there's a lot of heat that can go into water before it evaporates. So it has a high specific heat capacity. And specific heat capacity means that it takes a certain amount of energy to raise the temperature of water 1 degree Celsius. So, and just for reference, sand is about a quarter. It requires a quarter of the energy to heat it up. Water also has a high heat index. Okay. It takes a lot of energy into it before it can get hot. And it also is a heat reservoir. Now, the same thing, you might have heard the term energy sink. Well, water is an energy sink or heat reservoir. It means that it's going to absorb energy, absorb energy, absorb energy, absorb energy. But the temperature of that body of water will not change very much because there's a lot of ways that it can absorb energy before it heats up. Like I said, the molecules rotate, they stretch, they bend, they interact with each other through those hydrogen bonds. That's why water has a high heat capacity and it is considered a heat reservoir. So what does that mean in terms of our coastal climates and coastal cities? Well, we're going to do a little experimentation to figure that out. But that will be later on in the class. You have to be present for that. I can't do it by video. All right. So oceans. Oceans have a lot of water. Of course, there's a large body of water, so they make a perfect heat sink. They will absorb heat. And when the energy is taken away, which is the radiant energy of the sun, it's going to take a long time for that heat to dissipate. So during winter, coastal areas are warmer than inland areas at the same latitude. And the latitude, if you remember, longitude long, latitude this way, it is the position north and south from the equator. So the ocean covers 70% of the Earth's surface and contains 97% of all water on Earth. That's a huge volume. So the ocean is a body of water that it just soaks up all of that excess heat that comes through the day and from the atmosphere. All right, so we've talked about a lot of things, and I just want to quickly go over what hydrogen bonds are again. Hydrogen bonds, as you know, part of water, is a weak association between partially positive and partially negative ends of the molecules. So when that liquid's in motion, they're interacting on those polar ends. Specific heat capacity is the amount of heat needed to raise the temperature of 1 gram of substance, in this case water, by 1 degree Celsius. The heat index is the amount of heat absorbed by a substance before it gets hot. And heat reservoir, which is our big ocean, our big body of water, is a sink. It is a source of thermal energy that essentially stays the same temperature because that energy is absorbed into different interactions within that molecule and between the molecules. And then latitude is the angular distance of a place north or south of the Earth's equator. So if we think about all of these terms and how water functions, then we can have a little bit of a clue as to what's going on with our coastal cities versus our inland cities. Now remember, large body of water, heat reservoir. Just think about that heat reservoir.